So for this problem, as usual, the first thing we're going to do is draw the picture. We'll notice that this problem gives us x as a function of y rather than y as a function of x. So what we can see is that basically as we graph these, they are not going to be functions, right, with the vertical line test. You're not going to see y as a function of x. If I do x equals y to the fourth, it's going to look like this. So that's this flat guy over there. And now the other one, x equals 2 minus y squared. Let's think about what it's going to be when y is 0. That's going to give me x equals 2. That's going to say, okay, I'm going to try to draw it a little bit bigger than that. So let's try to draw it a little bit bigger. There's x equals 2. And then when x equals 0, y is going to be plus or minus square root of 2. So maybe like here. So I'm going to see my parabola going this direction. I don't really need it over here, so maybe I'm just going to draw this part of it. Okay, so this is my region, the region kind of between these two curves. This is the region that I want to revolve, and the problem asks me to revolve it about the y-axis. So this is my axis of rotation that I'm drawing here, and it's going to go around like this. So now if we imagine what this looks like, this is going to be kind of a donutty shape like that, right? Where my cross section is going to have a hole almost everywhere. It's kind of going, it meets in the middle, you see, because it's going around the y-axis. But essentially, we do have this situation where we've got an outer radius and an inner radius. So my outer radius is going to the curve x equals 2 minus y squared, and my inner radius is going to go to the curve x equals y to the fourth. So let's see if we can just draw this a little bit better. Maybe down here, it's going to be the same idea. I'm just going to draw it twice. So this is my outer radius. I'm going to be going to this curve. So R out. And what is the radius? The radius is x, right? Because that's distance. So this is going to be x, which is 2 minus y squared. And then my inner radius would just be this little bit over here or over here. It would be r in is going to be x equals y to the fourth. All right. I don't think that that's showing up very well, but essentially this is going to be Rn. So I'm going to set this up. One other thing I need to know is I need to know my limits of my integration. Now, notice that we talked about the radius being in the x direction and the thickness of our washer then is in the y direction. That's going to be dy. So I want to integrate in the y direction. So I need to have these points of integration here and here. They have to be where the curves intersect, but I need the y coordinate of those. So easy enough to set this up. So I'm going to set up where these two curves intersect. X is the same, so y is the same. So we solve y squared plus, well, I'm sorry, well, y to the fourth plus y squared minus 2 equals 0, right? Again, quadratic in y squared. I want a plus, so it should be plus 2 and minus 1. This should be y squared equals negative 2. Well, that doesn't give us anything. This would be y squared equals 1, which gives us y equals plus or minus 1. So that makes sense. That looks good. Um, so what I'll eventually get from my volume integral, I've got pi times the integral from minus 1 to 1 of the outer radius, which is going to be 2 minus y squared minus the inner radius, which is y to the fourth squared, all over dy. And yes, if you want, you can use symmetry to do 2 times the integral from 0 to 1. And same thing. It'll end up being the same thing. I just happen to do it this way. So I'm just going to keep on going. So square this guy, it's going to be 4 minus 4y squared plus y to the fourth, and then minus y to the 4 times 2 is 8. So this gives me this. All right, now let's evaluate that. I'm going to have 4y minus 4y cubed over 3 plus y to the fourth over 4 minus y to the ninth over 9. And then I'm going to evaluate from -1 to 1. So, right, so this minus, okay, so -1, so minus 4. And what did I do? Did something wrong. Yeah, this is 4. Must be 5. This was correctly 4. All right, so this is 1/5. This is 1/5. Okay, right. Very good. Because they should all add. Um, right, so the powers are gonna all be odd. All right. So, whoa, sorry guys. So this is gonna be 2 is this all these are the same. So 2 pi times 4 minus 4/3 plus 1/5 minus 1/9. So what I end up with is 45 in the bottom, right? What the heck is this? 4 times 45 is just 180. I need this to be bigger, right? It's pretty small. And then this would be 60. This would be 9, and then this would be minus 5. So eventually I get 2 pi times 124. So my final answer is 248 over 45 pi. Not a beautiful answer, but not terrible.